Yeah guys, now I'm doing a differentiation by parts. By parts it says integral of z, this is z, into ln z, the whole square dz. How do we integrate by parts? By parts we are going to use this formula. I'm going to use this formula, u dv is equals to uv minus v du. And then when we are using this formula, we need to use certain condition before we can arrive to this formula. The first condition, it says limit. When you are differentiating by parts, you always use this law, this condition that says limit. Where your ln, where your L, this L, it means ln log what and etc. Where your I, it means inverse. Any equation that has an inverse, you call it inverse function. Then this is trigonometry. This is exponential. This P is for polynomial. This P, it means for polynomial. Polynomial, it can be any equation. Polynomial. So using this condition, we can be able to solve any function of a by parts. How can we solve it? We must know this limit. This limit, we use it when we are letting a function, meaning that we always use limit. I'm gonna write limit here. Limit. This limit, it means that when you're given a function, you must always, I'm gonna write this general formula, u dv plus vu minus v du. This is v, this is u, this is v, this is u, this is u, this is dv. Then for this limit, any given function of a by parts, you need to let your given function to be u and another given function to be v from the same given function of which you are using. This limit, it gives you a way forward on which equation are you going to let to be u and which one are you going to let to be v. But from here, we always start with u. And we follow this sequence. For here we are given exponential. No, it's polymers. Polymers of which is polynomial. And here we are given ln. We're given polynomial. This L, it means that we are gonna first start. Actually, we are gonna start letting u to be our ln accordingly. Then if this ln, we have it here, it's gonna be u. Then the second alphabet of which is polynomial, it's gonna be v, of which we are gonna say this is the first step. Say let u be equals to, this is ln z the whole square, and v prime is equals to polynomials z. So this one and this one is derived, it's a derivative of z. This one is a integration of u. Then from there on, we differentiate this, we integrate this accordingly. How do we integrate? Do we differentiate dz is equals to, when we are differentiating ln z, we're going to take this exponent, put it here, this exponent multiplied by the base, which is going to be 2, into ln z. 2 minus 1 is 1, of which is going to be ln z. Then the integration of ln z, remember, when you are differentiating ln z, dy dx of ln x is equals to 1 over x. Always dy is equals to 1 over x. Then we come and say, using this law that say, when we differentiate ln z, it's going to be times 1 over z, of which we can write this as ln z divided by z. And again, integration, when we are integrating v prime dv dx dz, no, dz dv equals to z dz. This one, v prime is going to give us v. Then this one, this is dz. When we differentiate z, gonna be z. 1 plus 1 is 2 over 2. We don't add plus c. Then this is 2. We must note this is 2. This is 2. Then from here, you follow this rule that says the integration of u times the derivative of v is equals to uv minus the integration of v times the derivative of u, of which our uv, we would say, therefore, our equation is equals to v. Our v is this one, v is z squared over 2 times u. Our u, we say, is ln z the whole square. Then we subtract our v integration, our v, we substitute v. Our v is z squared over 2 multiplied by the derivative of du. We let du to be our subject of the formula. The u is equals to 2 ln z over z dz. Our du, we substitute du. The u is going to be 2 ln z over z dz. Then from there on, we cancel 2 and 2. Here we have 2 square, here we have z square, here we have z. Cancel this z, you cancel this square. So we're going to be left with, you see, we remove this 2 and 2 and this z and this. We are left with this now, of which you can write it in this form. I write it in this form, z, then z, dz. Then from here, From here, we again apply the limit condition that says you must always let u to be the function according to the alphabet, then the second function to be v according to the alphabet. But you must first start with u, of which when we come here and this, we have ln and z. This z is polymer, meaning is to the power n, of which our n here is 1. Then ln z, we say it L stands for ln, log, and etc. This is inverse. This is polymer. We're gonna, and we start with u. Then we're gonna say let u to be our ln, because it's the first alphabet that we are having, of which we are saying we're gonna have. We take this equation again, ignore this one. Let u is equals to ln z, then du dz is equals to 1 over z, and v prime is equals to v z, then again integral of this v prime dv is equals to integral of z dz, which is v is equals to z squared over 2. This is z, this is 2 over 2. Then from there on again, we come to this equation again. We multiply v and u, and v and the derivative of u. And we say, therefore, first we take it from here, then we say it z squared over 2 ln the whole square minus, put a bracket. When you put a bracket, from here to apply this rule v and u, our v and u, you multiply this and this, gonna be z squared with z divided by 2. Then you minus it with this one. When you minus it, minus v, our v is this one, is z squared over 2. Multiply by du, make du the subject of the formula here, of which is going to be du equals to dz over z. Substitute du here, multiplying v, going to be dz over z, of which is 1 over z dz. Then from here, this is z, it's gonna cancel each other. You cancel this and this. We're gonna left with z over 2. Then we take this constant outside. I'm gonna proceed here. We say we are having z squared over 2 the whole in z the whole square minus, when we multiply this into this, and give us negative z squared over 2 ln z. Then this and this is going to give us positive plus the function of, we said we're going to cancel this and this, of which we are going to left with z over 2 dz. Then we take these coefficients outside. It's going to be take this coefficient outside, it's going to be 1 over 2 integral of z dz. Then from there on, we proceed. Now we come and integrate this, since it's a single term, z square over 2 then z the whole square minus z square over 2 then z plus half. When we integrate this, it's going to be z square over 2 plus c. Then we can also write this format into 1 over 2 times 1 over 2 is 1 over 4 z square plus c. And this is our final answer for a bypass. You must note how do we use limit and how do we use this formula. Then number 3. Okay, now we are doing number 4, of which number 4 I say is a substitution function of an integration, and our function, it says the integral of cot square into t over 2 dt. They say we must integrate this. How do we integrate this? Before we can go any further, we have identities. Identities say that 1 plus, actually these identities, I call it from a formula guide, and this identity specifies this function. There are so many identities, and this function, then this is a general formula when you are differentiating cosec squared, and this we are going to use it when we are simplifying this function. Then the first identity say that 1 plus cot square a is equal to cosec square a. So for us to integrate these, we need to make cot square a the subject of the formula, such that we relate this cot square a with this cot square t over 2. How do we make it? We're going to make this subject of the formula cot square a equals to cosec square a minus 1. Then from there we take this cot square t over 2 dt. Then from here we don't have to do much. The only thing that we need to do here is to substitute. We know we have our a here is t over 2, then cot square dt. Then we remove these and substitute these where there is cot square. By substitution, actually you solve using identities, of which you substitute what correspond to the identities, of which these identities correspond to these. So we are going to substitute it here, of which is going to be, we're going to write this cosec square a minus 1 d. Actually, we say instead of a, we're going to put t over 1, t over 2, the whole minus 1 dt. Then from here, we expand this equation, of which is going to be cosec square t over 2 dt minus cosec integral of dt. So from here we come to this general formula that says the integral of f prime x cosec square f of x dx is equal to negative cot f of x plus c. So we are integrating cosec squared t over 2, of which our f of x here is t over 2, our cosec. Then when we integrate this, we first differentiate the function f of x. When we differentiate f of x, it's gonna be 1 over 2 t over 2. Agree? When we differentiate t over 2, it's like 1 over 2 t, and remember this is 1, this is 1 over 2. 1 over 2 multiplied by 1 multiplied by 1 over 2 is 1 over 2, minus 1 is 0. This is going to give us 0. 0 to the power, any number to the power 0 is 1. So we put 1 over 2 here, of which it's like this, and enter a derivative of f of x. This is f of x, this is our derivative of f of x. Then in an integration, when you derive, you need to do this so that it can be the same, so that you cannot change anything. Multiply by 2. Meaning this 1 over 2 is a derivative of t over 2. Then after that, this 1 over 2, you need to multiply it with the number that is going to give us, that is going to give you 1, of which 2 times 1 over 2 is going to give us 1. Meaning here, if it was 3t over 2, then we differentiate this, it was going to be 3 over 2. Then we're going to put 3 over 2 here, then we're going to put 3 over 2 here, then outside we're going to put 2 over 3, of which 2 and 2 are going to cancel each other, and 3 and 3 are going to cancel each other, then we get 1. But because we have t over 2, that's why we decided to put 2 here, multiply by 2, this is 1 over 2 dt, then this is a function 1. So when we derive 1, so from here we just substitute accordingly. Using this function is the same. The f prime x is 1 over 2 cosec f of x dx dt. Then you just write this as it is, of which it's going to give us negative cot negative 2 h1 negative is 2, is 2 into negative cot t over 2 minus the integral of a constant. It gives us a variable of that function, of which here an integration of 1 is going to give us t, so we're going to say minus t plus c. So when we simplify this, it's going to be negative 2 cot t over 2 minus t plus c. Here, number 5, it says we must prove that this integral function is equal to this. This is negative 1, of which is an inverse of Cauchy. The first step that you need to do here is to take this function as it is. This function as it is. By taking this function as it is, we make u the subject of the formula. You must note here, because we are going to include theta, but here we don't have theta. So we're going to say u is equal to, this is 5, equals to 5 cos theta, where our theta, it was a function, it was a variable, that it was an angle that was there before they wrote this, of which if we differentiate this, we're going to differ. Actually, the first step is to take this function, make u the subject of the formula, then include theta, of which is like this. Then again you're going to say, therefore, then you say theta is equals to cos u over 5. You do this, then you make theta the subject of the formula. Then from here you differentiate this. How do we differentiate this? When I say du over d theta equals to, when you a derivative of cos, derivative of cos is sinh, derivative of cos is sinh, is 5 sinh theta. Then you make du the subject of the formula. Du is equal to 5 sinh theta d theta. Meaning you take, when you make du the subject of the formula, you multiply this, the whole of this, with the theta, of which is going to give us this. Then from here, you come and take this again. Then you say du over u squared minus 25. Minus 25. Then from here, we do have du, we do have u. We're going to change this 5 into this 25, return into an exponential form of which is 5 squared. Then we say, when I say our du is 5, our du is 5 sinh theta d theta. Then our u we say it is this. Substitute accordingly. U we say our u is 5 cos theta the whole square. Because our u is in, because our u, they say u square, are gonna square the whole of which we say is equals to u. Then minus 25, minus 25, minus 25. Then from here, you can simplify it. When we simplify it, taking from here to here, it's going to be 5 sinh theta d theta divided by this sinh. This, when we, because here we have square, I'm going to multiply 5 square and cos theta, of which is going to give us 25. 5 square is 25, and cos theta is going to give us cos theta square minus 25. Now we are left with this. Then from here we factor out this 25, of which is our common factor. Going to be 5 sinh theta d theta divided by, when we take 25 outside, it's going to be 25 and cos square theta minus 1. So this, the root of 25, remember the root of 25, when you simplify this, it's going to give us 5, which is 5. 5 multiplied by this, and this 5 and this 5 is going to cancel each other. It's going to cancel each other, of which I'm going to cancel it here, just to not waste time and space. Then from here, we come and say the derivative of these, we said the derivative of these is these. Actually, from the, remember guys, when we arrive here, this identity that says square plus cos square is equals to 1, but we wanna do the reciprocal of these using sinh and sine, using sinh and cos, sinh square x and cos square x equals to 1. But you must note that always when there is sinh square, you put negative then positive, of which we're gonna make our sinh subject of the formula. Sinh square is equals to cos square x minus 1, then you put the whole. We're gonna remove this and substitute this accordingly using this identity. Then from there on, we are done. Of which is gonna be integral of sinh theta d theta. We say this is gonna be sinh theta, then this is gonna cancel each other. We are gonna get 1. Then when we differentiate 1, we're gonna get something like this. Then when we differentiate 1, here is 1, it's gonna be theta plus c. And remember, theta plus c, our theta here, this is our theta, then we substitute our theta. Our theta, we say that is cos inverse u over 5 plus c. Therefore, you conclude that right hand side is equals to left hand side. Thanks for watching our video. Don't forget to subscribe.